This is Marco Wu from eeprogrammer.com. I'm going to talk about two things today. The first thing is principal component analysis. The second thing is linear regression. Now, I'm going to talk about principal component analysis first. And now I'm going to set up the data. A is equal to 10 times 1,000 of random number. And B is equal to an array of 1,000 number. So let me make the plot. You will see the bulldog. Now let me change the scale. So because I generate the random number is from the x is 10 times the random number value. So the variation in x is much bigger than in y. Okay, so we preset the data. Now I create a rotation matrix. Okay, this is a standard rotation matrix, and this is R. That means I rotate the data 75 degrees. And I generate a set of new data called G. The size of G is 2 row and 1,000 column. Now I set X to be the first row and 1,000 column of the data, Y the second row, 1,000 column of the data. And now I plot it on the same figure. And I use the green dot. Now at this point I haven't used any principal component analysis. I only generate the test data. Now I use the principal component analysis. This command is PRINCOMP. I put the data in X and Y and find the coefficient. You can see it is as same as the rotation matrix. It's very close. It's slightly different, okay? But it is very close. Now, so the principal component analysis can help us to find the rotation matrix. It can know how much I rotate the data. Now, I add a constant to the data, the test data. I make the plot again. Now what you will see is that you will see an offset of the data. And I plot the data in red color. Now you see the offset, right? I do the principal component analysis again. You can see the coefficient is the same. It doesn't affect by the constant.
If your research or engineering projects are falling behind, eeprogrammer.com can help you get them back on track without exploding your budget. Let us know what you need. You'll find relief here. Visit eeprogrammer.com. We can help you.
Now, the second thing I'm going to talk about is regression. Linear regression is very common in data analysis. I have two sets of data. One set of data is input data, the other set of data is output data. You can see in the workspace, I have two sets of data. It's actually a constant times the A1 of the input data and the constant times the A2 of the input data plus another constant. Okay, so the output data is like generated by this formula, and input data is basically is A1 and A2, two columns of data. Okay, now we take help and regress, R-E-G-R-E-S-S. It will show you the information. Now, basically is regress take two inputs, Y and X. Y is the output, X is the input. And remember, when we have a two input, A1 and A2, but X is a three column matrix, because you need to include a column of ones in there in order to make the correct answer. STATS is telling you how good is the fitting is. It includes the R square, it includes the P value. So output data is equal to constant 1 times A1 plus constant 2 times A2 plus constant 3. I want to make sure you understand this, okay? That was how I generate the data. Now, how can we find constant 1, constant 2? Then we need to use regression. This is a very basic formula and very basic like data analysis. Now let's find the size of the input data. You see is 49997 data point and 2 columns. Okay, each column have 49997 data points. Now again, when we do regression, we need to include one more columns of runs in order to make the correct answer. Now, so in here, I found the size of the input data and add a column of ones. You see right now I have 3 columns, and the last columns are 1. And there are 49,997 of ones. Okay? Now this is the syntax. This is how you combine the data. Okay? Okay, now I put it into the regression. This is the syntax for the regression. Now, output data is the Y in the help file, and the X is this input data and all the ones in there. Okay, after I run it, you see the B, like this one, the first value is A1, second value is A2, the last value is instant.
In here you see the statistic. The first one is the R square, how it fit the data. The last round, the P value, what is the percent of chance this thing happen? The chance, okay? So this is the base of the linear regression, and this tutorial is the base of the data analysis.
If your research or engineering projects are falling behind, eeprogrammer.com can help you get them back on track without exploding your budget. Let us know what you need. You'll find relief here. Visit eeprogrammer.com. We can help you.